Problème du jour is we just added 20 and that is a minimum that is higher than the previous minimum that we already found. Therefore, we're going to stop going to the right. Therefore, we go back to the best minimum and then we go to the left. But starting at this point, we only have things that go, cubics that go up with no minimum there or maximum. It's just up, 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 up. And then the one between 2 and 3 has a maximum. Therefore, the maximum that we are looking for must be between 2 and 3. That's actually, was it 10 to the power minus 5 to the right of 2. But the green arrow, that is the next jump point, is here. That is probably the opposite W value that was stored at the moment we found this local minimum. Does it even make sense to have stored that at all? Either I should immediately store 2. I mean, this is a difficult thing. I mean, going to the left here just means you have to search for a minimum starting at 2. But apart from that, even if I store an opposite W value where the green arrow is, it should still not really jump there. It's pointing to a range that is not in between 2 and 3. I don't think I'm checking that at that point. It feels like I need a function that handles going from here to the maximum to the left, which then just follows all these cubics and then picks the maximum of 2, 3. That's a similar situation here. Where we wanted to jump to a point before the 6, on the left of the 6. But the restriction was like the red arrows, so that it had to be between 6 and 5. So then we found the 6 and then the cubic between 6 and 5, and then that had a minimum at 18, somewhere here. So we jumped through this value. And then it turned out to end up there. I think it's safe to say that in this case we always have an H direction, the direction that we want to search into. So the green arrow that is pointing to the left here, and a range. So turn that into a function, and then I can call that function also when we jump here. But first I'll turn whatever I wrote for this part into a function, I think. Okay, this is this code. So let's search for that. Okay, so we have a W value, that's a new jump point. In this case, this jump point is the value of W here, is the best root of the derivative of the fourth degree polynomial fit. I'll show that, what I mean with that. Should just run that. To have a 4 degree polynomial fit, but yeah, it was just like yoing. Let's find the next one here. This one. So we have fourth degree polynomial fit. It starts here, going down, 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 down. Now we have a minimum somewhere here, and then we go up, 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 up. And then we have a maximum here, and then we go down, 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 and a minimum here, up, up, up to infinity. And then the best jump point is this one, this minimum here, which of course hints that there was a minimum here, because we have to go to the right. So W at that point in the code is this value here, this W value. However, the red 6 is on the right of that. This is a tiny little bit before the 6. So it doesn't make any sense to actually jump here, because I know in advance that there is no minimum here, because I already have a cubic between 15 and 6 that tells me that it's just going down and down and down all the way down. So let's go back to the code. So this is that minimum, but the left, or it must be left of this point, which is 0.6. And wait a minute, that's not true. It must be left of 0.5, which is all the way on this side. So this holds. No, it does not hold, sorry. W is less than this value. So this whole thing is false. Now we get here. So right of exists as well. It's not equal to chain end. And W is less than the value of the right of point. So the minimum of the fourth degree polynomial fit here is less than 0.6 value. And then what I do is we check if we have a cubic between right of to the right. And that was the case. So this is not equal to unknown. And then we can just use the cubic that is stored in the right of point, so in 0.6, which is then the cubic between 6 and 5. And then yeah, I'll have to initialize and analyze cubic again. And then we can just set the jump point to the extreme of that, which is then 0.18. if you can still remember the graph that I just showed. But okay, there are other possibilities, like there is no cubic. There is no cubic. In that case, we just set W to right of W. So that is all the way to the right. That's the point furthest to the right that exists apparently at that point. And then we try to do another step to the right using either the scale, or if the scale wasn't calculated, then I just used the value of small step. And then the mirrored case here for going to the left. And then this whole block can be replaced with a function that I also call handle, like I have multiple handle functions. Yeah, maybe, I don't know, if a handle means that I make something up and then we pass W. And then the result of that is that it changes W if needed. Well, on the other hand, the other double values are return Boolean values, true or false, where if it returns true means that it was successful in changing W. Returning false means that there was nothing, so you just have to abort. But I don't think there's necessary to abort here at all. So maybe you should not start it with handle. It's not really the same as the other functions. What should I call it? A good name is important. So what this is doing is it takes a range into account. If it is outside, if it's inside a range, it should not change it. If it is outside the range, it should move it inside the range by preferably returning the correct extreme, minimum or maximum, of the cubic fitted between the 2 points that make up the range. Or if the range has is plus or minus infinity on one side, then we just make a step, which is then either the scale or. So how do you put that in a single function name? Still going to call it handle, I think. I'm calling the handle range. So it takes the range into account. Most notably that after this I can do assert debug within range, and that should be true then. So it makes W, it changes W if necessary to be within the range, and then of course optimally so. But they don't have a return value, do I? I don't think so. I don't like the word handle though. I could say clamp to range, but it's definitely not clamping. I can, no, it's not clamping. let's say move into range. Yeah, I like that one. So I need to make a new function then, just a void function. I could have it return the W value. Could call it adjust for range maybe. I mean, you would say maybe I should do this, but yeah, doesn't really matter, I guess. The problem I have with this is that every time I change the W value, I also have to change the expected LW, so that the function value, which of course depends on however I found the W. Expected means, let's say we jump to the extreme of a cubic fit, then the expected vertical value is the value of the cubic at that point. But there are multiple functions, so I can't just call this and then still know how to set the expected W value afterwards, because that depends on what this thing internally did, which cubic it used, unless I set cubic used to, we have a cubic used member, to whatever cubic I used. However, sometimes we don't have a cubic, right? I mean, in this case, for example, I'm also not setting expected W. In this case, we don't have an expected value. In both cases. Okay, so then what I do is I'll set cubic used in case I'm actually using the cubic to jump to an extreme. I'll not do this yet here, but I'll return true or false based on whether or not a cubic was used. To do that. So in this case, it's kind of random. But yeah, so in this case we do return true. Cubic was used. And in this case, also and then in the other cases, we do not have that. So I can fall through to the bottom and then do return false. I probably also should reset have expected LW. That is the default then. Yeah, or I can maybe, nah, I don't know. I can do this, all of this just inside the function itself. So we're going to do it differently. Let's reset this thing at the top. Maybe we should first move it to a function. So it looks a bit weird to add a thing here. So move into range. And that's going to return... It doesn't return... No, it does not have to return anything really. Move into range. Okay. Keep void. So let's start with resetting this. And then if we don't use a cubic, I'll just return. Yeah, that should do it. Handle local extreme. Yeah, let's not put it in between the two handles. I'll just add it here. It's a function that is used by the others. So I think I want to put it higher though, then. Now let's keep the same order in the .cxx file. So I'll move it above update energy. Okay, I think this should still work now. Didn't change anything, I just turned the piece of code into a function. Yeah, also note that if it is already in the range, then W should not be changed. Huh? So that is the case, because then this is false, and this is false. In that case, I did not touch W, so that means that I should also not touch have expected. W is false. It's just not good. So I should reset that here, I guess, instead. So it means a duplicate, but well, better than having that bug. So W was now changed to something, but we are not using a cubic, and therefore also don't have an expected value. And then this is a bit double at the bottom, because we enter it while this is already true, but that depends on the caller. Currently that's the case, but I'm also going to call this function from elsewhere, so it's probably safe to just keep these two lines together. So now the function will be called, and we should go here, and we already see it actually, that the green arrow here points to, yeah, this whole cubic was redrawn, and the arrow is drawn, I think, from the function. So we just jump there. Everything still works. And on this breaks, if we press space again, we run into the error that we jump here while the range was there. I mean, it just didn't make any sense. Let's see if we can find it, where that is. The error happens here. Yeah, it doesn't help much. Fix me what to do in the case this fails. Yeah, but it should never fail. Every time I run into this, which is quite often, then something else is wrong. Like whatever we have been doing. So this happens, this problem happens basically as a result of setting the jump point to this value. That now should be adjusted. And that jump point is set after we discover that we must abort the H direction here. So we can scroll up and then see if we can find that. Let's click on this. Oh yeah, this one. Yep. So the last restart point is this, and then we'll have to manually go into handle abort and see what happens then. So there's the rerun 45. Here. And yeah. Okay, we found the minimum at 0.20. Yeah. And now we're going to discover that it is, we already discovered that it is a local extreme. And then we are going to discover that it is higher than the one that we already found. And then we're going to call handle abort. This would happen pretty quick, I think. Set as local extreme, do some drawing. If it is a minimum, then test it it is, you know, not higher. So the new minimum isn't better than what we found already. Return false, which then means that well, we enter handle aboard the H direction. Aborting, exploring right of the minimum at minus 55. So I didn't write that yet, so it's definitely not done. And last extreme cubic is set to the best one. Change the H direction to now going left. So we are now been back to the best minimum, and now we go left. And then here it happens. I set W to whatever we stored then as being the best point to go to if you go to the left, which is somewhere here, which is definitely not the best point at all, if you ask me. So that would be line 85. It even calculates that. It's kind of nonsensical then. Yeah, see this, I think, oh, well, that was already calculated. Never mind, yeah. I wouldn't like to calculate a cubic at this point. Well, then it takes some CPU, you know, cubic, I don't know, 6 multiplications or something. Well, here we are not taking the range into account at all. This is just going to return, I think. It says we did not use a cubic. Maybe I should just look at the source code. Let's go to line 856. Yeah. Now here it is, initialize range. So after that, I should just call. I don't know, how did I call it? Move to. Did not call it move to. Arg. Move into. And now the annoying part. If this now changes W, then I have to do this again. So we do need a boolean. Or, no, wait, it's doing it itself. Yeah. Okay, so this function automatically updates these two values. The only thing is that I feel that if this was a calculation, then it's a bit of a waste to do it here. Like, it would have been better to not do this and then just test the return value and then do it. Like a return true if we still need to do that. But, yeah, no. Not in this case. I'm gonna speed this up in the future. It's now a bit slow, but okay, it just finds this minimum and then We find also in several steps that maximum. And now we find this minimum, and now it works. See, now it completely updated the whole thing. We're no longer jumping here, we're now jumping, nobody knows where we jump to. I think it did everything. The only time that we stop so we can look at the graph is when it leaves a certain function. I think it didn't feel like leaving the function because it probably jumped to 2 and then recognized that 2 was already known, and now it goes for a minimum, and yeah, so it went a bit too fast. Let's look at the debug output instead. So I'm looking for... So this was the last handle local extreme. And then we went to handle abort, H direction. And now we have this line here. So the attempt to jump to minus 56, that is here, was thwarted because that is larger than the left off, which is minus 78, which is 3. So left of, it must be left of 3. This is right of 3. Well, then it starts talking about minus 85. That was quick. No, I think no, actually not. Minus 85 is the maximum of this cubic. So it had to be between 2 and 3. In fact, super close to 2, which is at minus 85. And this is then again 3. And then it says the new probe is too close to an existing sample. I mean, it's even rounding it off here. They are not exactly the same. It's like 100 thousandths difference. But it is so close that it's just reusing 0.2. Which means that we do not leave the function. We re-enter it while reusing 2 as the maximum. And it says we're using the maximum of the left cubic because that extreme is closer to the center of 1, 2. So now we had 2, and then we have 2 cubics, 1, 2, and 2, 3. And because 1 is closer to 2, its center is also closer to 2, so it's using the one on the left cubic. 1, 2 is the left cubic, and 2, 3 is the right cubic. And that cubic has an extreme like add 2 almost. So yeah, this is the step, 100 thousandths, 9 millionth. So we find now the local extreme at minus 85. Again, that of course is wrong. But yeah, without writing more code to skip that or deal with that correctly, it is what it is. We just find that the maximum now to be 2 at minus 85 again. And now it has 4 samples, 0, 1, 2 and 3. So 0, 1, 2 and 3 fit the cubic well enough. So it's a good fit. And then those 4 are used to fit a 4th degree polynomial. That is the best 3 of them. It doesn't say which 3 it uses. Weird. So the 4th degree thing then has 3 local extremes. This one that we found, and another one. I mean the 4th degree thing is like so we have 1, 2, 3 local extremes, and the derivative is then 0 at this point, and this point, which is then a 3rd degree polynomial. And we can do a long division where I divide it by w minus this extreme, because we already know that that is a root. And now we are left with a cubic, which crosses 0 here and there, which is easy to calculate then. So we have one at minus 105 and the other one at minus 67. And yeah, we have to go to the left, so it's going to minus 105, which is off my somewhere here. But yeah, this thing is going down to minus infinity, so it's not a good test anymore to go that direction. I wonder what happens next. I guess we just crash at some point. So minus 135 is the next attempt. And then minus 200. Oh, really? Thought it would just go to minus infinity. So what's this assertion telling me? Well, clearly it must be of type down. We're just going down, down, down. It's like, it's just this parabola that you see here. So why would it have a problem with the assert? Oh. That would be an up. We're dealing with a cubic maybe, that is... Oh yeah, here. There's a super tiny non-zero coefficient for the cubic. So if x becomes very small, well, I don't think it's very small yet, but minus 204. Apparently then this becomes, this starts to play a role, this part. So it's not a cubic. Sorry, it's not a parabola. Not really. Which means that this thing looks like a parabola here, and then it goes down, but if you go far enough, and then really the 200, that is pretty far, that's like outside of my monitor already, there it goes up again, for some reason, for floating point around over reasons. So it did find a minimum here. Maybe you should just draw that so we can actually see what is going on. So I need to still be able to see minus 205. Let's say minus 210 or something, I don't know. The whole function, the test function is no longer visible, so it's so small it is. And again, we go find this minimum, and then we find this maximum, and then we go to this one, and then we start to descend here. Boing. And then we are here, and then it crashes. I still don't see a minimum here, not by a long shot. It's just going further down. Confusing. We have to look better. Let me look here. This sample node. This is being called on a sample node, which is derived from sample, which has a label. So we can print label 23. So we're calling this function on 23, and then next should be 22. We have a next that was passed to next label. That's 22. So far so good. And then the cubic was initialized. Well, it should not have not a number stuff and Looks like that. Well, that's totally a parabola. That's just the coefficient of the third power of W is 0. So 100% a parabola. And then we have derivatives, of course. The derivative in 23 is just given by this function. Which is very positive. Just the slope here. And this slope here is also positive, but less so. How do we find that? Slope. That would of course be that one. Positive, but a lot less positive. Okay. Slope check. That means that both of the sign of the derivatives are both positive. 1 and 1. Yep. And this is of course true. Neither derivative is 0. The easiest first. If the sign is different, well, then we know that there is an extreme in between. Yeah, if it goes down here and up here, then in between there must be a minimum, or the other way around. But in this case, if the sign is the same, it is either up or it could be an S shape, and we still have a maximum and a minimum in between. So we should. That's 1 is unequal 1. No, so we go here. The signs are equal, so it must be either going up, going down, or going up, down and up, or down, up and down. Or very unlikely both derivatives are 0, but that's not true. This is also false. Wait a minute, it's true. Neither derivative is 0. It's true, of course. That's what I meant. So we enter in here, and then we make an analysis. We analyze the cubic, and that would be the cubic between these 2 points. And then that cubic does not have extremes, so this should be false. Oh. Well, it does have an extreme. It does have an extreme. It doesn't have an extreme here. Only one, but okay. Does not have a minimum though. I think this is not correct. What would get extreme return if it doesn't exist? I'm asking for a minimum. Now a cubic has either no local extremes or 2 of them. And I'm interested in the minimum. And then we say has extrema, plural, so does it have a minimum and a maximum or doesn't it? That returns true, which I think is then interpreted as we have both a minimum and a maximum, because what else could it be for a cubic? And then I call get extreme, which should return the minimum, but that doesn't exist. So this is probably not a number, which then compares with something and then returns a value that we don't want. That's my guess. Infinite. Yep. Okay. We can work with infinite. Not the number is annoying, but the infinite is not less than W value. So this is also false. No, not also. Wait a minute. This is false because this is true. This is false. Might as well have been minus infinity, by the way. So it's not really working already. Or next W is less than infinity. That's true. So we should get here. Okay, well, the assessment is correct in that the minimum, it doesn't really matter if it was plus or minus infinity, by the way. So we have the minimum is at plus infinity, which means that it's not in between 22 and 23. If it was minus infinity, it's also not in between 22 and 23. So because it's not in between those two, we get here. And that means that it must be going up or down, which then depends purely on... Oh, it is up. I'm such an idiot. Of course it is up. So that is 1. Okay, so this works. This is 1, and therefore it's going up, like the ASCII art here. Now, it's exactly what it's doing. But before we get here, this assert fails. What does the assert say? If only one extreme would fall in between the samples, so this says that extreme at infinity is not falling in between. And then this says if the other one does fall in between, which means then there is only one extreme that falls between the samples, then the derivatives can't have the same sign. So the idea is that if there is one extreme in between here, then either it must look like this or it must look like that. And then the signs should always be different. I guess then the other extreme also does not fall in between. So I don't know what about this, but the other extreme should be minus 85. Ah, finally our not a number is there. Okay, we found it. We found it. Takes so long. Takes so long. So doing a compare with not a number gives you weird values, like always true or always false, something like that. And as a result, it thinks that the not a number falls in between. Always false, apparently. So it doesn't matter which side we put the not a number on, it is always false. So one way to fix this is negating it and then putting an exclamation mark in front of it. Of making this larger than and then a negation thing in front of it. Then the larger than is still false and the negation makes it true and then the assert goes through. In which case we would have that if get other extreme returns not a number, then the assert doesn't give a shit. And I would say that not a number does not fall in between those two. Which is good enough for debug code, actually, so I'm tempted to do that. On the other hand, the other extreme does exist and is minus 85. So yeah, not happy with that get not a number. So how is this calculated? So one of these must be not a number then. So let's have a look at a cubic. I'm trying to subtract infinity from infinity, it seems. Or what am I doing? 2 times infinity minus infinity. Why is that not a number? Because infinity minus infinity is unknown? Yeah, probably. Okay, so the whole infinity thing doesn't really work. Yeah, I'll definitely won't get a minus 85 out of this. 2 times infinity minus infinity? Minus 85. Come on. Okay, both are infinity. And why? How is this calculated? Initialize, right? Yeah, we divide by 0 here. Does my cubic even have an inflection point? Probably not. That means this is also plus or minus infinity. That's why these things are infinity, perhaps. Then the critical point is shifted. Yeah, this is like the textbook example of a non-numerically stable function. Really have to improve this. Be right back. the cubic. That's where the infinity comes from. Well, one of them. You could say, well, just detect that you're divided by 0, but it's not that simple, because everything is more or less, and it could have been that this is not 0, but just plus or minus epsilon, which then gives me plus or minus something that is incredibly large. And if then you do if then you use that to subtract two things from each other, I think that was the another function where it subtracted infinity minus infinity, it still goes wrong. It's just an incredibly large number, plus or minus some incredibly large number, minus also an incredibly large number, and then the difference must be accurate. No, it's not going to happen. So it's not that easy. Well, the function inflection point itself, I mean, if you really wanted to know where the inflection point is, then this is just the formula. At most I could assert if a coefficient 3 is 0, because that would not work. What the hell is returning infinity anyway? If you divide by 0, it's just undefined period. Oh, this is a test. Already thought this code is. I fixed this already. It's also a super unstable code. So we're looking at the wrong file. Or not. Now I'm confused. Wait a minute. No, it's just directory tests. Cubic polynomial. Yeah, this is the class. Sorry to say, but it just can't be 0. If this is 0, then it's undefined. Which then means that I cannot call inflection point unless I first check that it is not 0 by calling this. Let me have a look at how stable I think the rest is. So this is not stable, and it is normal code. But so tiresome. Yeah, get roots is my stable function. So I'm not doing the exact same thing, it's doing it for polynomial, where this can be at most a problem. Right. And the other one, that is a problem, I think. So I can just copy this code then. No, it's not a problem. Cubic. So a quadratic polynomial, that's definitely... Man, I have to implement it multiple times. Code duplication, horrible. Yeah, I'm not really getting it, but let's go with that. Hmm? Hmm? I just fixed a function that wasn't even used. Great. Not wasting any time here. It was called get zeros, and I renamed it. So I thought, well, it's totally going to not compile anymore, but it still compiles. Plus, it's a horrible code duplication. I really hate this. Nevertheless, we also have cubic polynomial. It is still not good. I guess this is calculating the roots of the derivative. So it's still more or less the same code, except that instead of using coefficients, blah blah, we have to correct for the fact that we first need to take the derivative. So let's compare it with the other one. Which then or should be the same as that parabola thing. Okay, I don't understand this part. If I convert this from... No, I have to understand it. If this is 0, then it's a straight line. If it's a straight line, then it crosses 0 here. And if that exists, then we say that we found one root, otherwise we don't have any root. Makes sense, doesn't it? Yeah. And now I'm having a function like coefficient 0 plus coefficients 1 times w plus coefficients 2 times w squared plus coefficients 3 times w to the power 3. And then I take the derivative of that. That means that we have this instead of this. Which means that we have to make this translation. Coefficients 1 becomes 2 times coefficients 2. Coefficients 2 becomes 3 times coefficient 3. And coefficient 0 becomes coefficient 1. And there we have coefficient 1, so that should be 2. Multiplied with 2. And here we have 1, that becomes 0, that becomes 1. And 1 becomes 2 times 2. And 1 becomes 2 times 2. And this becomes 3 times 3. Okay, and then it should start looking more like what they have above here. This other thing is just not dealing with linear functions. No, okay. Gain something. You have the square of coefficient 2, which means, of course, this is the square of 2 times something, so it's 4 times 0, 4 times the square of that. And then 1, 3 or 3, 1 is the same, and here we have 3. So there's a 4 missing here. D is apparently not the same as this D. So this is 1/4 D. We can divide it by 4. That's the same as that thing then. If that's less than 0, then return 0. But we also want to do this. I should update the thing at the top, I guess. So we want to keep this. Oops. Well, no, why not? Move it to here. Where the roots out is called extreme out. I'm not convinced that I should return 0 there. Well, I should return 0, but I'm not convinced that I shouldn't put the inflection point in 0 if this fails. There. And this D is actually 1/4 T. Do I see this thing back? Not really. Oh, there's a different formula. Never mind. That's the whole point. You should find this one back though. Coefficients 2 times coefficients 2 plus a sine square root. Well, close enough. A half drops away against that. And then this half drops away against the fact that this is actually a fourth. Well, there. It's probably cracked. And no, I'm not convinced. This just takes a sign of coefficients too, so I might as well remove that. Doesn't change anything. I can't seem to match them. This is not the same as that. You can multiply this one out, then you get minus coefficient 2. Minus a half times the sine square root of t, which is a quarter. It doesn't drop away. Can't believe that this code is wrong. It's not wrong. Problem? Shit. I'm gonna start over. Sorry. Just don't see it. Don't see where I made an error. So it's just not true. This should be multiplied with 2. No, actually not. Well, yes. No. Let's write it out. The roots. So the roots are like a minus b. Minus b. This is b. Plus or minus the square root of d. Divided by 2 times the coefficient of the third power, which is this one. That one, whatever. Usually called a. Which is, again, divide by 2 above and below. So then we get minus the coefficient of that plus or minus a half times the square root of d. Divided by 3 times that. So it was correct. So this is the plus thing and this is the minus thing. However, I should be using this one. Let's begin here. So after we check the sign of d, we can make a signed square root. So we have here the square root of 1/4 d. And we do that here as well. 1/4, which turns this into half. So now it's a signed half square root of d. With the same sign as a coefficient of 2. And then I should do this one. Closest to 0. Okay, which is that? This one or that one? I think this is the minus one. That's this one, aka that one. left most extreme index is 0 if and only that is true, otherwise put the minimum index 0. Yeah, I'm not sure, but I think it's this index that I should use here instead of 0. And then I still have to replace index 0 with 1. And index 1 with 2 times 2. I think. So this is the real D. So this is the signed square root of D. I think that's what went wrong. Confused the two. So I multiplied this with 2 because it was coefficient 1. And coefficient 1 is now 2 times coefficient 2 because it's a derivative. And this should be the signed square root of D, but the only thing that we have is the half of that. So you have to multiply that with 2 to get back the signed square root of D. And then we can divide by 2. Above and below the division line. Now it should look like this, more like this. It doesn't look like it's at all. Never mind. I think this is correct. See, we can do the same trick for that one. So now we already have this one. And then hopefully so I don't need this anymore. Yeah, no, I did. I only have the signed half square root of D. So God knows what that was. To go back here. First have to do this. Let's first do that after setting the first one. Setting the first one, that's here, right? Yeah. Well, that should be the other one then. That is this, where I still have to replace these things, I think. The coefficient 1 becomes 2 times 2. Yep, it's 2 times 2 and 3 times 3 for coefficient 2. And then because I only have the half, you have to multiply this with 2 as well to correct it. And then we can drop out. Oh shit. This one is not signed. It's it's okay, I think. Yeah. So this is what we divide by, and here we have minus a half times 2, so that becomes a minus. And then the half times that one drops out. And then the sign is, yeah, unknown, but the sign should be part of the signed half square root now. So I think now it matches. Thank God. And then we had still this. It's just an assert. Yeah. That's not the restriction that I have here. The restriction that we have here is that if the leftmost first is true, oh, what does that mean? The leftmost extreme, aka the smallest one, in index 0, if and only if leftmost first is true. So we can do that one. If not, either it's not true, or the first one must be less than the second one. Or leftmost true is true. Or then it is false. Then the first one should be the minimum. The first one is the minimum. That means first one must be the minimum. How do you check that? I think this. I'm not sure. No, probably these parentheses. This I equals something. Coefficient 3. Even kijken. If extreme out 0 is less than extreme out 1 as before, then the first one is the one on the left. And that is correct only if the minimum must be first. If the minimum is on the left, which is only true if the coefficient is less than 0. Yep. I'm only 80% sure that I didn't make a mistake, which is horrible. Well, apart from this kind of typos. Extrema. Well, assuming the function was used, I would say this looks exactly the same as before, so it works. This still doesn't work because I didn't address it. I addressed something else. Also numerical stability. Yeah, that's a new assert. So you're not allowed to call inflection point when the coefficient is 0, because that would be highly unstable. That would return infinity apparently, plus or minus infinity, or not a number. It's all equally bad. So I have to fix this function. Let's fix this function. It is bloody just deeper code to begin with. Yeah. That ain't working. So this is returning, if this is returning 1, then the only extreme is stored in index 0. But then I don't know anymore if it is a minimum or a maximum. Looks like I have to duplicate the code again. And I need to remember the sine square root of d. Why? Equals, it is used here. Height. Print on. Test if you have extrema, use in height. That's it. Yeah, okay. Let's copy the code from get extrema, and then remember this as if I can remember that. So. And we have to design that one and that one. Starting with copying all this code without comments. Way too much. If then the derivative has a single root of 1, but it's not a minimum nor a maximum, so I should just return false here, I think. That is. What do I want in that case? Don't even know. Just return. That is, we leave this variable at not a number, which indicates that you don't have an extreme. That's what I want, of course. So in this case, is 0, then the derivative has no roots. Yeah. And thus the cubic has no extremes. The determinant is that, blah. I mean, duplicating code is one thing, but duplicating, nah, it's horrible. It's just all horrible. That's what it is. We're gonna have to store D, I think. Let's just forget about the 1/4 here to save one multiplication. I want to know which is the minimum, which is the maximum. So we have to pretend that this is false, which means that this is false. So index minimum is 0. The minimum goes into index 0. Yeah, obviously. Okay, and this must be the signed square root, which is just the square root of d with the sign of coefficients too. Calculate the root closest to 0. That's super annoying because do I want to calculate this? I mean, close to 0 is one thing, yeah, nice, but I mean, is this the minimum or is it not a minimum, you know? And then I pretended to know that. So this would be the maximum then, because index minimum was of course 0. Which should be the maximum. That doesn't make any sense whatsoever, dude. Why would the maximum be close to 0? You could put the 0 anywhere you want. Plus we have to remember this, I think. We have this thing. So in this case, we have to set the signed square root back to 0 to just return. Wait a minute, the cubic is a parabola that does have a maximum. Well, it depends on the sign of c. I don't have coefficient 0 here. Comment wasn't updated. Shit. We're looking for a maximum. Sorry, we're looking for extreme type. So let's say if that is extreme type maximum, if we are looking for a maximum, and so that is true, and this is also true. Then, well, if this is true, if it's larger than 0, then this goes to plus or minus infinity, left and right, so we have a minimum. This corresponds to having a minimum. So if you're looking for a maximum but we have a minimum, or we're looking for a minimum but we have a maximum, then this is going to be false. So if this is true, okay, I confused myself. What was it? Larger than 0 means a minimum. Yeah, so this means that we don't have the extreme type that we are looking for. Which means I have to set that back to not a none. Yeah, not a number. Which we do as follows. Just use this again. Otherwise, we do have it. And this is 0 now, and we have to store it. What am I storing here? I don't even have extreme out. Oh yeah, I still have to fix it. Otherwise we have what we are looking for, which means that I have to store it in that. And then for unknown reasons, I prefer an unequal here, or maybe a less than. And swap these two. It's more consistent with reading this. So we have a root at 0, blah blah blah, set the critical point to 0. I don't know why. Hopefully that is the minimum. I doubt it. actually, but okay. It's not printed. The smallest one must be in index 0 if leftmost, well, that was leftmost first is false, so this is true, so the assert never fails. And then this one is false, so now we can really check if this is true. It means that if wait a minute, I think that maybe I understand it now. No, still not. I mean, how I thought how closer to 0 is related to, but never mind. So if d equals 0, I don't want to get here, really, at all. I should just return here when it is equal to 0. Duh. Then this should never happen. This should never happen. The sign of this thing is the same as the sign of that thing. So if this is non-zero, then the whole thing is non-zero. And therefore, this should never happen. Which is a good thing, because sometimes I don't even want to calculate this. What you really have to do, well, I also can't do this, so just forget about assert at the moment in any way. Oh, this sightness has a different meaning to make it better. I want to have it. I want it to have the sign of extreme type with a minus sign in front of it. Oh, okay, yeah, that's not the same as just copying the sign of coefficients too. But I need that for this calculation, obviously. Okay, so Popo. I'm just gonna delete a lot of code. We want to set either this one or the other one. depending on which type we're looking for. So theoretically, if extreme type equals extreme type maximum, okay, so this is always true. This is already set. And then this is the absolute value of the signed thing that we calculated. Oh, I already have that there. Yeah. Square root t. Yeah, if I ever have to override this anyway, because it's a different sign, I might as well go back to the half thing. But, well, might as well. Not really. Not really, not really. Mm-hmm. Or I do, and I multiply it here with 4. No, just leave it like this, I guess. Although it would, it saves more than one multiplication. It saves this one and this one and this one. And I have to add one back there. Well, it saves 2 multiplications. Well, okay. I'm gonna leave it like this for now. Well, I have to convince myself that this is the maximum. Why the hell would this be a maximum? I think I'm going to ask ChatGPT, which doesn't know, but hey, it prints out stuff. And then we can correct it instead of having to type everything myself. I don't want examples. Why are you flooding me, spammer? The only thing I wanted was this. Stupid examples. 200. Hmm. Substituting Q. Actually equals D, I think. Yeah, D must be positive. So yeah, I said absolute value is equal to the square root of D, and the sine of Q equal to the sine of B. But if you square, then the sign doesn't matter anymore, so we just get D, and D must be positive. So we assume that D is positive. Which, by the way, must be assumed positive. Thus, it's too lazy. Okay, I think this is correct. I mean, it seldom makes a mistake with copying stuff. But in the meantime, let's scroll off. I'm going to assume that this is a Wolfram example output, so therefore correct. Hopefully. Certainly if it results in 0, right? 3ac minus 2b times a half q plus b plus a half q plus b squared. Oh. That's the same thing. So minus 2b and then the same thing squared. A half q plus b. Minus 2b. Yeah, okay, so that's true. Expand a half q plus b squared. That is a quarter q squared plus bq plus b squared. Expand the full expression. We lost a c there. I don't really care about this c, but it's 3ac minus 2b times a half q plus b plus, and then it filled in this. Yes. The expanding minus 2b times that, which is then minus bq minus 2b squared. Substitute 3ac minus bq minus 2b squared, that is this thing, right? Plus a quarter times q squared plus bq plus b squared. I think that's still correct. Simplify the expression. Notice that minus bq plus q cancel out, leaving, thank God, only q squared. So 3ac minus 2b squared plus quarter q squared plus b squared, which then gives us 3ac minus b squared plus a quarter times that, and we can fill that in again. Q squared is still 4b squared minus that divided by 4, means that that drops out and that drops out, so the result is 0. Good. Having established that that is correct, which it should have been. Now the real question. The second derivative is 6ax plus 2b. What? Oh, so because it was lazy and blah 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 blah, I reached my data analysis limit. That's a new one. That's a Wolfram or something. Fuck. Got cut off here. No, then I have to do it myself. Very annoying. Very, 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 very annoying. So what do we know? Q is the square root of 4b squared minus 12ac, which is the same as 2 times that, but it has a sign of b, so times b divided by the absolute value. I can divide that internally by the absolute value of b. So let's say I divide this one by that, which means that internally we divide it by, because the square root is all positive, so I divide this by b squared, which then gives 1 minus that divided by b squared. And then that drops out, so this is 2b times the square root of that. And we fill that into six ax plus 2b. No, I don't. I want one of my solutions. It doesn't really matter which one I take. Choose that one. Yeah, so that if you fill in a half times q at this position, then we get b times that. which then simplifies to b times, and then divide by b, divide by b. In other words, the square root minus 1. And if we fill that into this, and I hope that the sign is always the same. Well, that means that the sign of this thing divided by 2 is also the same. So I fill it in this, the sign must always be the same. Well, if you fill that in, you get 3a times this plus b. And of course, this 3a drops away against that. And then we multiply this out, we get b times the square root minus b. And then again plus b, so this is what is left. And that has the sign of b. Well, that's all nice and dandy, but I'm not sure if I made a mistake, of course. Maybe you should just write a little program. Yes, let's write a C++ program. Test is so much easier. Why didn't I think of that immediately? Just plug in some random values, generate everything, see what the result is. Totally going to do that. CD projects, CD machine learning, and again source tests. Oh, I lost everything. CD Cairo window. It's as if we were doing machine learning. We're doing Cairo window. Test. Because of course I'm going to use polynomial. vi foobar.cxx include polynomial.h. Using namespace gradient descent int main include IO stream standard cout hello world C++, standard C++ 20 foobar. Polynomial uses almost equal, so yeah, I need utils. Okay, that sucks. Minus I repo base. What? debug.h? That should be defined in. Oh, it isn't. No debug.h. Wait a minute, I went one too far. No debug.h, so we need also, but after that one, I think. Though, does it really matter? Repo base CWS. Gradient descent is not a namespace name, but because I'm including polynomial.h, that is put in math, I think. Yeah, it's just in math. Well, let's see, they use the math then. As long as I don't have to type a namespace. Well, apart from standard, of course. Never going to do. Hello world is working. Ta-da, we have polynomial. So I can now create a polynomial. Let's call it polynomial p, even though that looks like a prime. And the polynomial takes, what does it take? Because my constructor here int number of coefficients. We don't have debug. A vector. Oh, it just creates it. Oh, it just number of coefficients, and then we have an empty thing. If I want to print it, I need debugging. Shit. Is that true? Yep. Well, I don't really need to print it, I guess. How many coefficients do we have? 4, because it's a cubic. Now printing would be damn nice though. Then I need to link with a lot of stuff suddenly. So you have to do define CW debug and more. Probably going to complain anyway. Oh, I need to include sys.h at the top. And libcw. Oh, really? Yeah. Nothing of this is easy. Unless I just use CMake. I guess I'll do that because, yeah, come on. Add executable foobar.cxx. I don't know, nothing else. Target libraries for foobar include this. That's the whole list of stuff. Don't mention constructor initially. Oh, now I have to pass the variable names. This a string for the symbol. Well, what do you say? String? Like that? Is that going to work? Standard string? No, that should work. Compile. I think it compiles. And then, of course, we don't know where it ended up. I'm just going to do the whole thing. VI machine learning inf.source. For aliases here, intro test. Oh, that should be done automatically. So resource full bar, and we have no output. That's correct. Full bar.cxx. So now I have to set the kernel, but you can just start with printing stuff. Print p. Still failed to type it correctly. Still print nothing. Okay. Probably not good with 0 polynomials. How do I fill this thing? Just calling this set but true. Okay. You can do that. So P0 is 3.0. Now it should print something. Three. Ta-da! Doing this with symbols would be way better, wouldn't it? Oh my god, I can do that. I wrote my own symbol thing. Why not use that? Set of hard-coded values and then God knows what. Just do the symbols. Yeah. It's a little bit more work, but so I'm not using polynomial then. Do my symbols support square roots? I suppose so. Not even sure. Something with symbol. Symbol. Yeah, symbols is defined in symbolic. Quit. Symbolic. I have no square root. I do have power though. I think I can do the to the power half. That should work. Oh, fuck. Sorry. Symbolic power square to. Yeah, you can. Oh, it's an integer exponent. But that's to the power of. Expression. You can just do one expression to the power of the other expression. Definitely can do to the power and a half then. Should have had made a square root as well. I made a square. Why not a square root? One extension coming up. constant as a realize of with two things, I suppose. Constant realize int. Realize ed. Yep. Enumerator, denominator. So that would be half. So how is this going to work? I need to include, let's say, I think everything goes in one header here. Yeah, just symbolic.h. That includes everything. So we have to include this and then hope for the best. That is not going to compile. I feel it. File not found. Symbolic. Failed. Something failed. No, it's still file not found. Ever? The only difference is that wherever I linked with that, I'm also linking with Cairo window. To symbolic. Oops. I don't know. It's still failing. And it keeps compiling the same thing. Why? Okay, that's better. Should be able to part it like this. I need Jeff. Okay. It just requires you to use Cairo window. Very boring. Oh. We have symbols. Okay, so what do I want? I want something that looks like my test suit. Just copy it from here. Foobar.cxx. That works as follows. We make a symbol. Let's say symbol X. And I make symbols for the coefficients. A, B, C, D. That's enough for... oh, those are constants. I want to have symbols. So I just need more symbols then. I think A, B, C, D. And I want to make a function. Just copy it. Just copy it. My function is the cubic. Kant op. Plus D. that prints cubic. It's not how I had envisioned it, I must say. So I did not make it an expression apparently. Maybe I don't need a function. I just need an expression. How do we do that? Huh. I don't know. It should be, but I have to realize the thing as well, I think. Confused. I need existing code, otherwise I don't know how it works anymore. Here's one. Yeah, that's a derivative. Then total energy should be 1. What is total energy then? Energy is just an auto-reference of something. And energy 0 is energy 0, 1. Pointer to pointer to an expression. No clue. I'm just gonna guess something. A times x. We have lift off. I don't need you. Oh, I can just make it up. Okay, so we want a cubic. Surely we have an to the power. It's part of that. Yep. There's my cubic. Okay. Auto-reference derivative is cubic derivative x, I guess. The derivative with respect to x. If it compiles, it works. So I'll just try it, and it compiles, so it works. I'm not printing it, however. Well, that is probably good. Yeah, the derivative of this thing is the d drops out, and then we get c 3 times a times x squared plus 2 times b times x. So that's correct. And then we can make a thingy called q. Is that a function or not? Nah. Auto reference q is, and I had made up a q, I think, in Drupal here. This, I think this is correct. Be nice to be 100% sure though. So let's do the derivation a second time. D, so the determinant, let's begin with the determinant. The determinant of the derivative is b squared. How do I extract a coefficient of that's probably not possible. Now all too much. But let's do this very dumb, as in the derivative a is, and then this was a derivative, where I'm going to write that a little bit different, plus c. And then these are the coefficients. So what normally goes as the first coefficient is usually called a, and that is in this case 3 times a, as was printed. And b and c. Derivative b is 2 times b, and the derivative c is c. And then the discriminant of that quadratic is b squared minus 4 times a times c. Yeah, but then of the derivative, of course. So the derivative d is a derivative b d c. Okay, let's say cubic is no, it's just f of x is that. The derivative is then the f accent of x. derivative. And now I want also to know what the hell d is. So the derivative discriminant is this thing here. Let's see if that is still readable. Yep. So 4 times b squared minus 12ac, which is correct. 4 times b squared minus 12ac. And now we're defining how I derive this, so basically in C++, but okay. We're going to define two roots of this thing. Now let's calculate. Well, can I do that? No, I can't. No, let's just define them here. So auto x0 is minus c divided by b plus a half times a q. Except that we don't have a half. How do I make that? It is a constant. Symbolic, it's just going to do constant a half. Wait, does that work like that? I'm not even sure. Normally you have to realize those things. Symbolic. I guess we'll see. If it compiles, it probably works. It does not compile. Oh wait, undefined q. Oh, I didn't define q yet. Yeah. Oh, that is what I first wanted to do. Okay, I'm going ahead of myself. So I want to define a q that is basically, I told that to ChatGPT somewhere. Let q have the value such that the absolute value of q equals the square root of d and the sine of q equals the sine of b. So that means I don't have absolute value support in symbolic, but I can just set q equal to the square root of d. That would be power dt. No, I defined the square root. Haha. So the square root of d. Now it's positive. This is my q. But I want it to be have the sine of b, so we have to multiply it with b and then divide it by the absolute value of b. But the absolute value you can hide inside here by dividing this by the square root of b inside it. Square root. Let's just print a q here. Forget about the d in front of it. This gives us a q equal to this. Well, apart from the 4, I think I recognize it. Let's see what I had here manually was 2. Wait a minute, what do I have? Times 2b times the square root of 1 minus 3ac divided by b squared. Now this is a times c divided by b squared. And then also times 3, but also times 4. So if you remove the 4 from the square root, then you get 2b times 1 minus 3 times that. So it is the same as what I had. So this was done correctly, I would say, yeah. Yeah, my symbolic library likes abbreviation. So if you remove the 4, then you get an extra constant here. Well, it doesn't consider this to become simpler, because a 4 or 1 is both a constant, and 12 and 3 is also a constant. So it's shorter, it's more compressed to write it like this. Okay. Now I can define my x0. Let's say define both. X1. See what I had. So x0 was minus c divided by b plus a half times q. And x1 is this one. Where I think the A and B and stuff are the cubics coordinates, coefficients, sorry. So not the dA, dB, dC, but really the cubic coefficients. And then the interesting question is, what happens if you fill x0 into the cubic? So we must substitute x with this and then work it out. Is that even possible? I think it is possible, and then I have to make this a function. And then you can do that. But let's be lazy and just work it out. So I don't know, cubic to cubic of x0, and then let's fill in x0 everywhere. And the cubic of x1. Oh, wait a minute! I don't want to know. I don't want to know the cubic. I want to know the derivative. Derivative. The derivative was done by taking the derivative. Oh. Yeah. Well, then. Okay, this sucks. I'm not sure anymore how to do substitution. If at all possible. I don't know. I just don't know. Just gonna hard code it in. So now I want to use this, or already that one. That is you have a quadratic. We have a quadratic where we have dA, dB, and dC. So yeah, that's a quadratic function, and we fill in x0 and x1, and then we can print the derivative at x0. Oh, like that. How cool is that? Equals this. And the derivative at the other point equals that. What? Let's see, it doesn't work. You have to call realize. I think it works like this and realize constant. And still it wants to have the same column. I hoped it would forget about it. I just ignored it. Disappointed. Very, very disappointed. It should have resulted in 0. Okay, why is this not 0? I did manage to verify it with ChatGPT to be 0. Well, first it claimed it would not be 0, but then I did this one manually. And then it repeated me, and then it was suddenly 0. And then this one eventually was also 0. So yeah, but definitely should come 0 then. What? What is wrong? Well, here I just work with q squared. I have to go to bed. So it assumed that q squared is 4b squared minus 12ac. Q squared. Oh, I've got it again. What's that I say there? 4b. This squared gives me that times b squared. So there's 4b squared minus 12ac, because the b squared times that is again nothing, or 1. Still looks like the correct q. And if you use that q for x0. This one is even easier, the one that I did. Way easier. This is just, it contains a q squared. I mean, x1, No, it's after doing something mysterious with the Wolfram Alpha that we got this. Let's put in q squared. That at least should equal something that we already know. So yeah, this is of course just correct. 4b squared minus 12ac. 4b squared minus 12ac. And we have this for x1. B minus b divided by 3a. x1 minus b divided by 3a. That the q dropped out. Huh? No q. There must be a q in these things, which means there must be a square root in it. There's a square root in this one though, but that does not look correct. There's a q in here. What? How come my q just disappear? It is not good. Hi, Pause Bunny. I should go to bed, so just really seriously. Minus b plus a half times q divided by 3a. And q contains a square root. How then can x1 not print a square root? Don't tell me symbolic is broken. Can't have that. It's not good. What about this one? This one? Is this one good? Maybe it is good. Maybe the whole q just dropped out. Well, actually, the square root dropped out. But I don't believe it, really. No, I don't believe it. Anyway, the x0 ended up as that. So you have the minus and the c, and then divided by is done by multiplying with the inverse of. Which is then b plus a half times q, and q is b times the square root of this, which is d divided by b squared, or d This is db squared, so that is 2b squared, that's 4b squared, sorry, 2b, so squared is 4b squared, divided by b squared is 4. And then here we have dA is 3a, so we have minus 12ac. And that is still there. And then divided by b squared. So this looks good. This is good. Oh, I see it. Ah, yeah. A half. You can't put a half in here. I don't know how it interpreted it, but not like a half. That's for sure. That took me long enough to see. So now at least x1 also has a square root in it. Because you can check it. If these are two roots, then the product and the sum must be very simple. Very simple. So we can test that as well. Okay, this is x1. Does that look correct? Divided by 3, divided by a. And then we have a minus and a b plus a half divided by 3 and divided by a. Times q. So this should be q then. And that's the same thing as before. Well, that must be good. Okay, so x1 looks good as well. I really don't understand why these are not roots. If I just fill them in this cubic, really, it should be working, man. Let's print or calculate or both x0 times x1. That's the multiplication between the two roots of a quadratic equation is I forgot, but it was something simple. Let's see what the result is. No, that doesn't look simple at all to me. At all. No. No. Either my symbolic fails in simplifying this, or they are not roots. No, maybe I should try it using Wolfram Alpha. Instead of my symbolic. Disappointing. If the optimization of my library is wrong, then this might still be 0. So maybe it is just 0 and it doesn't show like 0. In which case I should be able to manually reduce this to 0. So try that. Copy. So is this 0? Is the question. Where to begin? This square root is the same as that one. Let's multiply the a in here. Let's multiply the 3 in here. Let's start simple. 3. This times 3 is minus 1. This times 3 is a half. Other terms are not there. And the 2/3 here. Nope. Can multiply the a in maybe. So this becomes, or it drops out against that one. And this one drops out. That's clearly already a simplification then that failed. How is that possible? Cha. I want to replace q, substitute cubic, because I think cubed will just drop out until we only have q squareds left. I thought I had a q here. There's a correct q. Could put that one in. So the square root is printed as to the power half. And then this is shown as a multiplication. Division, yeah. So that's a multiplication with b to the minus 2. And then you can put the c there instead of here. another multiplication there. And then this 2 can be moved inside the square root, making this a 4 and this a 12. In other words, if we highlight this stuff, then we see, I forgot something there, but that's pretty much Q then. B times the thing that is the square root is Q. And here we have something that should be very close. Now if I remove this, it becomes Q. So that is B times Q. But yeah, it's never going to drop away, is it? This doesn't have an A in it. This does have an A in it. This whole thing, however, can be divided by 3A, which then removes that and that, and that and that. We can put the B outside, and then we get here a B, and no B. So definitely a factor of 3A missing in this term. Because if we square this, you get B squared minus B times 2 times this thing, in other words B times Q, plus a quarter times Q squared. And like I said, I expected that the Q drop away, that we only are left with Q squared. So this should be, we have a minus B times Q here. Oh, also a minus. Oh, it doesn't drop away, it just gets larger. Yeah, anyway, then I would still have to divide this by 3A before that happened. Nope, not getting it. It's a failure, and I really have to go to bed, so I'm gonna give up for today. Good night. Way too late. I'll be back.